All right, hey everybody. We are doing activity 4.3, writing a unique quadratic function, and you can find this on page M1-60, M1-60. All right, so the idea is we'll be given a point or like some key feature of a quadratic function and actually write the function rule. So we're going to do a vertex form one first, and then I'll give you an example on how to do it in factored form. But before we get there, let's determine which form we should be using. So on page M1-61, part A, it gives us a minimum point and y-intercept. So knowing that I have a minimum point, that is actually the same thing as a vertex. That is the same exact thing as a vertex. So if I'm given the vertex, I am going to use vertex form to write my function. I'm going to write vertex form to write my function. All right, so part B may not seem like there's any key features, but when it gives you an x value and the y value is 0, like here and here, when the y value is equal to 0, those are x-intercepts. Those are x-intercepts. And another word for those is roots. So if you see them called roots on your assignment later, don't freak out, just know that it's referring to x-intercepts. So hey, if we're given x-intercepts or roots, we're going to be using factored form. Factored form. Okay, part C. We're given 3 different points, but we don't know if they're actually key points. We don't know if they're vertices, y-intercepts. We don't know if they're, x-intercept solutions. We don't really know a lot. So we're going to say none there. There's not really going to be anything easy to plug that into. Part D, kind of the same thing. Gives us 3 points. They all kind of fall on a line because, their y value is 3. So there's going to be nothing really for us to do with that one. Nothing easy to work with. Part E, though, it gives us some x-intercepts and an additional point. Since we're given x-intercepts, we can go ahead and do factored form. Factored form for that. Part F, given some roots. Remember, roots are the same exact things as x-intercepts. The y values are 0 on those points, and so that's going to be factored form. All right, and then hey, part G, Max hits a baseball off a tee. That's 3 feet high. The ball reaches a maximum height of 20 feet. So that's your key word there. When you're given maximum or minimum, it's really just referring to the vertex. So I'd be using vertex form to do that. I'd plug those points into vertex form, simplify, and we'd have our quadratic function. All right, so let's move on to the next page. We're actually going to write some function rules given a vertex and a point on our parabola. So if I were to draw this, just to give you a better idea of what we're actually doing, here's our vertex at -3, 4. So I'm going to go down through this point. My parabola is going to continue. I'm going to be doing the same thing on this side. So that's kind of what our parabola should be looking like when we graph it. But what's the function rule that produces this parabola? Let's figure that out. So we have a vertex, -3, 4, passes through point, -4, 1. Let me actually go to a new screen. Might be a little bit easier to work on this, to show my work. Okay, almost ready. Whoops. All right, let's get through this. So again, we were given a vertex. We were given a vertex and a point that it passes through. Point that our parabola passes through. What were those? I don't remember. So we got a vertex of -3, 4. Vertex is at -3, 4. And then the point that was given to us is -4, 1. negative 4, 1. Okay, so since we're given a vertex, we're going to want to use vertex form to write out our function. So what that'll be is, well, vertex form is f of x equals a x minus h squared plus k. All right, so hey, they've given us a lot. They've given us almost everything we need for this, but we do have to solve for a. We have to solve for a. So maybe first I'll label where we're getting these things from. So the h value comes from this, the k value comes from that in the vertex. So the vertex is your h and k. The point we pass through, that's how we're going to get x. The x value is this. And then f of x is honestly the same exact thing as y from algebra 1. It's just a cooler name for it. So f of x is where we get the y value. All right, so if I plug in all my values, f of x is equal to 1. A is what I need to solve for. X, I'm replacing with negative 4. See how I'm subtracting my h value? So I'm subtracting h, which is negative 3. I'm subtracting negative 3, which makes this positive 3. Squared plus my k value of 4. All right, so now you just have to work through this, simplify, and then solve. So a times negative 4 plus 3 is negative 1. I haven't done anything with my 4 on the end. I keep working on this equation. Negative 1 squared is positive 1. And then 1 equals a, because a times 1, that's the same thing as just, 1a. To solve this, I would need to subtract 4 from either side of my equation, and I get negative 3 for a. Negative 3 for a. Once you have that, we're just going to plug things into our function, and we are done. So the actual function rule for this is f of x is equal to our a value, negative 3, times x. Remember, I'm changing the sign of my h value in here. X plus 3 squared plus my k value, which was 4. That is the function rule. That's the function rule that will pass through this vertex and also this point. I know it's kind of a lot going on there, but with some practice, it's going to be like not so bad. All right, let's get rid of this. Let's do one more while we're on it. Okay. So the next question, it gives us another vertex that we pass through. Gives us another vertex. And it also gives us a point that we're passing through. So let's get ready here. We'll write our vertex and our point. So this is from part B of question 3. The vertex is 3, negative 2. And the point that we're passing through is 4, 0. 4, 0. All right. So maybe I can write vertex form one more time. It's f of x equals a x minus h squared plus k. All right, start plugging some things in here. So the vertex, that's how I get h and k, h and then k. The point, that's where I'll get x and also f of x. Trying to write that small to not get confused. Okay, so let's plug all this stuff in and solve for a. So f of x is 0. So I'll have 0 equals a. The x value I'm replacing, remember I'm replacing x here with 4. I have a positive h value, so I'm really just subtracting 3. And then my k value is minus 2. K value minus 2. All right, so let's just work through this. Solve for a. 0 equals a. That's going to be 1 squared minus 2. 1 squared is just 1, and 1 times a is just 1a. or we could just write it out as a. I still have subtracting 2 on the end. So let me add 2 to either side. Add 2 there, add 2 there. So 2 equals a. Solve for a. 2 equals a. A equals 2. All right, so now let's put all that stuff together. F of x equals 2 times x minus 3 squared, and then minus 2. That's our function. That is the function that has a vertex of 3, negative 2, and is guaranteed to pass through this point. So that's really it. I can show you on the graph, right? If we go back here, this is where I got those values. We started off at our vertex, negative 3, or positive 3, negative 2, and we went through this point of 4, 0, just like that. But it actually passed through the point, of course. Do the same thing on this side. And that's what our function would do if you plugged it into Desmos. That's exactly what it would look like. Part C, again, we're given 3 points, but we don't know if they're key features or not. So we're gonna say nothing for now. We don't know what the function would be. I can teach you how to do that in a later video. But that will do it for this one. Thank you guys for watching. See you in class. Bye-bye.